In the summer of 2022, the Mars Society conducted our first ever high school engineering design course and competition. The results were fantastic. Let's hear from our founder and president, Dr. Robert Zubrin, about the inception of the program.
As a grad student back in the 80s, I said this would be a great way to teach high school. And well, this summer we decided to do it. We organized an international competition. Now, it was all done by Zoom, but we took, anyone could volunteer, and then we organized them into teams. One in Asia, one in Europe and the Middle East, and 3 in North America, more or less organized according to time zones. The contest included not only listening to a bunch of lectures of experts on Mars missions and technologies, who we did not attempt to get to agree with each other, because in the real world they don't. The students had to sort them out to figure out who they wanted to listen to, and then do their designs and write them up and present their designs. And then we gave each team a half hour to tear apart the designs of the other teams, and then a half hour each to refute the attacks on their designs. Okay, and the latter two aspects are not ordinarily done in university engineering design competitions. This was new.
It involves a number of things. First of all, learning and being inspired about Mars exploration. Second, engaging as a team as an engineering design class, which changes the relationship of the student to knowledge. Instead of it being, how much of this do we need to know for the test? We got to find this out so we can create the best design, and so we can refute the other design. So the knowledge, instead of becoming a burden, becomes both a tool and in fact a weapon. So there's that aspect of it. Then there is presentation. Then there is debate, which fires both the competition itself, and then the subsequent debate and rebuttal really revs up the competitive juices.
We strongly believe that the New Era mission has the best mission because it also by far the most cohesive of all the reports. As another example, we have made logical choices from the beginning all the way to the end, and our landing site directly ties into what we want to take advantage of, which is abundant ice, intriguing geology, and proximity to methane-concentrated land. So in addition, we can also justify our choice to stay in a relatively high latitude. We're supporting our crew with a robust thermal control system that will efficiently heat the interior of the habitat using the heat released from our reactors. So just in this one example, there is already an exceptional synergy among our science, engineering, and human factors objectives.
Thank you, Venkata. Hello everyone, I'm Arya Ozade, and I'm going to talk about Nourish, which is the name of our greenhouse, and it does exactly what its name means. So the system of growing food in the New Era mission is hydroponics. Aeroponics was not chosen as it's a lot less reliable than hydroponics, and if something were to happen to the plants, like maybe something gets contaminated or nutrition isn't supplied enough, the plants are likely to die a lot faster than plants grown hydroponically.
For the oxygen production and all those things, we're going to be mining ice on Mars and using all of those to directly gather all the resources we need. By mining this ice on Mars, doing evaporation to remove all the contaminants through a water filter, we're going to be then putting it into an electrolysis chamber where we can produce oxygen and hydrogen at very high production rates.
So 2,000 pounds of food, really a variety, but we're going to make sure we have protein. So we're going to 3D print meat and use cell division on ship. So that way we don't have to bring full-scale animals, which weigh a lot. Well, we can bring the cells and we can use the cell division to create meat.
And so our experiment is looking into how colliding dust particles create electrical discharges, and how these electrical discharges in turn trigger a series of chemical reactions that eventually destroy the methane on Mars.
The rover has 3 chemical analysis systems present on it. The first form is called SOLID, the sign of life detector. This uses 2 main parts to look for Earth-like life, searching for the repeating polymers that Dr. Benner has told us to watch out for. The second system is called the Microfluidic Life Analyzer, or MILA. This is designed to test for 500 plus different biological compounds, including organic molecules and amino acids from small liquid samples.
Firstly, we have our selection process, which will consist of several elimination stages, similar to what the ESA and NASA currently follow. The final round will have 10 shortlisted candidates, as you can see on the slide, out of which the 5 that make the original crew will be chosen based on their abilities to work as a team.
It's been quite a pleasure, and it's gonna be tough to make the call regarding the teams. I think I'm looking at the reports, and they're so detailed and very thorough. So thank you for putting the time, and your team, and every team has to clap their team members. It's an international effort, I think, and you've done a magnificent job.
I think, at least for me and my team, that was a really amazing part of the experience. We know that in the real scientific world, when you say something, you will get professionally and sometimes even personally attacked. You need to be ready to defend yourself. And it was great to have that opportunity in an environment where we felt safe and confident that everybody else would be looking at this scientifically and working together to help all of us improve our missions overall.
So for me, apart from just getting to know more about Mars itself and like you mentioned, the writing the report, also it was a great opportunity to practice more soft skills, such as teamwork, presenting in front of a large audience, and in my opinion, that is something that is very important because a lot of people nowadays focus on really lack those very important soft skills.
The level of work in this contest is way beyond high school level. Really, the sort of thing one might expect from a junior level university design class.
And to watch these kids work was amazing, and to see the product that they came out with was I would say higher than most science competitions.
I think the process of broadening our horizons via this program, we've been able to look out more for internships and stuff. There's actually a NASA program that is able to connect high school students with space-related internships, which we're planning to do some exploration on for next summer.
A feeling we can't really put into words. We're in the front seat for a new era, both in science and society, and we're so happy that we were able to be a small part of that by being here. Thank you to Dr. Zubrind and Mr. Burke for organizing this event, and thank you to our mentors, Dr. Brian White and Miss Ashwani Ramesh.
So as you can see, this was a really successful program. I'm really excited to see how we can scale this up to a wider pool of students, but that depends on your support. So think about how many young people you'd like to affect, and please give generously.